when we're going to be trying to incorporate the obstacles into this, the same way that our main player object has a name associated with it, an instance name, our other objects are going to need instance names as well. So this one has been referred to as obstacle 01. I prefer that versus obstacle 1, 2, 3. I like obstacle 0, 1, 2, 3, obstacle 0, 2, obstacle 0, 3. So when we get up to 10, it's the same number of characters long. That works okay. We will, in coming weeks, look up and use different ways of dealing with our obstacles that we have without having to refer to them by name, which will make our code a little bit easier to write. It won't be quite as verbose, and we will work towards that end. But otherwise, this is the same document. So I have my obstacle. My obstacle doesn't have all kinds of cool states, but it's good enough for now. So here's my obstacle, obstacle 01. Here is Bob. He is my player. And if at some point I decide I want to change the name of Bob to player, so I have a more generic style code base, a nice thing that we can do is inside the code here is I can do a find and replace. So I could find all instances of the word Bob and I could replace it with the word player, and then my code would be updated and it would be more generic. So if you want to do something like that in your code because you don't like that yours says one name, mine says another, and if you want it to be changed, you can highlight inside the code. Okay, can't get to it there. But if we choose Command F, that's find and replace. We can see Bob, and I could replace it with player. So if I wanted to change all instances of Bob to player, so then, because Bob just is more of a silly name, and now that we're building this into an actual full-fledged example where it's going to be a full-featured kind of interactive game, I may want to have a more serious naming style. So if I choose Bob, replace it with player, I can say replace all, and it will rewrite my code so that everything is now with the word player. So anytime it found the word Bob, it changed it to player. And if I test my movie, I'll see that I get 16 error messages here because it's now looking for 16 instances of an object named player, but his name was still Bob. But if we change his instance name to player, now we're up and running again. And we'll notice that now Bob is having some issues chasing after his obstacle because, well, the obstacle is now chasing. Ah, I'm running. I'm going to get you. No, you're getting me. I'm getting you. You're getting me. So that doesn't work. So what we're going to have to do is figure out a way to get that to behave a little bit better. You also notice that I've currently turned off my background layer just so that I can see what I'm doing, my world. So I've hidden that. It just makes it easier while I am working. Now, it's not going to be a whole lot of effort to update that. Currently, we have the world updating here. And instead of world, if I now change this to obstacle 01, and because this involves a lot of typing, I'm going to start migrating to our shorthand version, where instead of using obstacle1.x is equal to obstacle1.x minus speedx, the shorthand version is we just say minus equals. In programmer speak, this says take this variable and set it equal to the variable minus speedx. That's what it does. It's a very common way of referencing things. If you look through other people's code, you will rarely see it written out in its full verbose style, like in line 36 here, world x is equal to world x minus speed x. But you would see world x minus equals speed x. So that means subtract speed x from the x position of the world, subtract speed x from the x position of my obstacle. So now we can see that my little beetle is able to catch up to this obstacle. So we can very easily make that obstacle pinned to the world in our project. So phase 1 is complete. The object moves with the world. Moves with the world. Phase 1 is done. So now phase 2 is to find out when that object is intersecting. Now, we can do that right here. We can write in a conditional statement and we can say, hey, if this object is hitting this other object, do something. But because your project is going to probably grow to include a half dozen, 2 dozen, 3 dozen, 4 dozen obstacles, enemies, things that we're colliding with, it sometimes is easier to take care of that in its own function. It helps to organize your code a little bit better, and I'm going to advocate that as the solution. So we get to write a function. Because right now, if we look at our main draw function here, it's starting to get long. And if we just keep adding to it, it's going to start getting really long. So what we're going to say is check collisions. Anytime we try to call a function, we do that, we call it by putting parentheses after it, and at the end of the line we do a semicolon. That is the proper syntax for what we need to have happen. The advantage of doing it this way is it helps us to keep our code organized into more discrete chunks or groups, so it's easier to find. We have our key pressed function right here. So we have the key pressed function. Now if you find when your code is getting really, really long, if you want to consolidate some things, so I can look here under my key pressed, I can consolidate that by highlighting, and then you can click the arrow and that collapses the code. So that just makes it, your window when you're looking at it is not, it's not quite as big. So we've now made it a little bit smaller as we're looking at it. I find that makes things a little bit easier to look at sometimes, especially as your project grows and grows and grows. So now we're going to figure out what check collisions does. So check collisions will be a function that we will define, and check collisions is then going to check and see, did one object, our player, run into our second object or obstacle, and then if so, it will make something happen. So we do that by defining it by saying function check collisions, and we do check collisions parenthesis close parenthesis colon the word void curly brace, and then hit return, and you get your nice closing curly brace, and it's ready to type. So that's the basic way to define a simple function. If you organize certain logic within your program into functions, it's like good housekeeping. It keeps things a little bit more organized, and I guarantee you will be a little bit happier. Otherwise, you're going to be looking through line upon line upon line of code and unsure of what is linked to what kind of is tied to what. This gets things organized into like little folders or groups, so then you can find them a little bit easier. So now, what we need to do in plain language is if player is touching obstacle, then do something. So that's kind of the plain language. That's not the code that we need, but that's our plain language. So now, that's sometimes in programmer speak referred to as pseudo code. So it's fake code, it's pretend code, it's practice code. It's, you write out what you want to have happen first, and then you start writing the actual code that you need. So now we can say if, and now we specify what we want to have happen, and I'm going to fill that in a moment. And then we'll have a curly brace, and then this is our do something. This is our do something. So the something that we're going to start out with is I'm going to just have it trace out a message. We'll just say ouch. So it's going to just send a message to the output window of ouch, so we know when that's happening. Now, the nice part in Flash is it has a built-in collision detection algorithm or method. So we don't have to do calculations based on, well, if this object's x position is here compared to the x position of the other object, and the y position compared to the y position of the other object, if they're within half of the width or half the, and come up with, you know, whatever method, half width, half height, or left to right, top to bottom calculations, we can just simply say if player dot hit test object obstacle 0, 1 is true, then we get to do something. So if the player is hitting obstacle 1, it's going to send a message. It will trace ouch. So hit test object is built into Flash. With 2 movie clip objects, Flash is able to detect when one object's bounding box is intersecting the other. If you have hundreds of objects on screen that you're trying to check collisions simultaneously, then using hit test object is not necessarily going to be the most computer or processor friendly. It's not the most efficient algorithm for hit test checking, but it is a good one. And if you've had to write collision detections in languages that don't have built-in methods, this is nice. Because it's just, is this object hitting this other object? And now we can check that. So our main loop will call check collisions. Check collision says, hey, if the player's hitting obstacle 1, trace out ouch. So we can go here, and now we can see it traces it out. It stopped tracing it. So when that's occurring, it starts spilling out the word ow. Adding in the health requires us to use our text tool, and we're going to make some text. I'm going to put my text up here on the top, and I'll call it health. Type a colon, and just put a couple numbers in. Now after I have done that, I can make my text box big enough. You can choose whatever font you want, you can choose whatever color, you can choose whatever size makes you happy with your project. I would encourage you to choose a contrasting color so that when your background artwork is showing, you can still see what is there. And that will make it easier. Now if I run my project, we'll come up and see it says health, and my health is 0. Now, having the health text field is good, but we want to be able to change the contents of this text field. To be able to do that, we need to be able to access it through an instance name. Now, something else I didn't point out on the text field is you will notice that in the text tool properties, we have an option of TLF text and classic text. I'm going to go for classic text. We have an option for static, dynamic, or input text. We want dynamic text. Dynamic text says we can have an instance name, and this text can then be updated through code. Static text is just that. It's static, and it can never change unless we physically type in that. Input text is where you would solicit input from the user of your project. So if they were inputting their name, they could type in their name. Then when they play the project, you would know their name, and you could call them all kinds of funny variations of their name. And that would be something that you could do. So I have a dynamic classic text field that I'm going to provide an instance name on. This instance name, I am going to call it health text. That makes sense because then we will be referencing it. So in my properties, it's now health text is my instance name. It's classic text, dynamic text, and I've now set my font, I've set my size, and I've set my color. So that's step 1. So I have an instance name, classic text, It's dynamic text. It's not static or input. And now it's a matter of referencing that inside my actions. So in the actions here, we're going to need to somehow keep track of what is the player's health. So we can just set a variable. So I can say var health, and it's a number. And we'll start out and just choose a nice round number of 100. So I'm going to start my health at 100. If I run my project, I'll see I've got nothing except a little font should be embedded, blah, blah, blah message. We'll deal with that shortly. If I want this health to be changed or updated, we're going to accomplish that down here. So after check collisions, it would make sense to update our health text. And the way that we're able to do that is by saying health text dot text. So we're changing the text property of this text field. So our health text field will change its text, and we'll set it equal to health. And then we put the string or the letters we want to see inside quotation marks, thus it turns green. Then I do a plus sign, and after the plus sign I will then have my health number show up. So it will now show me the word health, a space, and then it will put the number of what my current health is. And if I needed to put some other value after it or some other word, I could put a plus, another quotation mark, and put, if I wanted it to be points or something like that. So you can make the string equal to whatever you need or want as part of it. I don't want the word points on there. I was just showing so you can. I just want it to be a number.
So what's the
Currently, if I run it, it tells me I should embed my fonts in my health as 100 or 00 instead of 000, or it should actually, technically, it should say 100. But if you notice now, if I do this, if I change this to 567 as my starting number, just to show, well, notice now it says I have a health of nothing. So what we can start to realize is the problem is the message that we received down at the bottom, which is font should be embedded, is exactly that. This text here has not been embedded. If I look into my library, it's not embedded. So what's happening is my project only has the character outlines that I typed here. I didn't type a 1, I didn't type a 5, 6, or 7, so none of those numbers were able to show up.
Which means they typed a 100.
So to make this embedded, we go click on the text field, go into our properties, and then there's a nice embed option. So you click where it says embed, and now we can choose which characters we want to embed. So I'm going to just give this a name. So I'll call it Trebuchet since I'm doing Trebuchet. I don't want to do all because we'll notice then that's way more characters than I need. I don't need all my extra kanji and Arabic and everything. I don't need 93,000 glyphs. All I need is uppercase 27, lowercase 27, numbers 0 through 9, and punctuation. I could subset those if I was really trying to eke out performance out of my project. So I could embed only the characters I want. I wouldn't have to necessarily embed all the letters, but I'm giving myself some flexibility here. And when I do that and say OK, if I now look at my library, you'll see that now that font has embedded into my library. And if I run my project, we'll see now it can say 100. Or if my starting health is not 100 but is 365, and run it, we'll see now it says 365. So it's capable of showing me all of the numbers and letters that I need. So we have to embed it. So step one, make the text. Do you have my line 9?
Yeah.
And then you have health text.text equals.
Yeah, it's just health number.
So to
69.
prove whether yours is working or not, I would recommend change the line 9 to some other weird number combination. Run your project and make sure you're seeing that number. If you are, then your project works. If you're not, then it's broken. And then we need to fix it.
Oh. I thought it was fantastic.
Mine started working. I didn't change anything with it. Just started working.
Broke it. Then you broke it if it just started. If you changed nothing, then no. Oh, but did you embed the font when you hadn't embedded the font before?
No, that was I had a very fun. I tested it and this I posted it and then I failed it.
That's great. Left is 100 here. Good. Confirm. Yeah, it's working. Are you going back and forth? Okay.
Mine says undefined property.
Of health text. Called it health up here. This one is called health text, and then health is actual represents the number.
So,
This is
oh,
so that is called health text, but then. But then you have your health, which is the number. So this represents the number. This is the word or the text field. Just update the text field. You take that text field's text, set it equal to this word, that word plus whatever the current number is. Wow, yeah. Me too. We're gonna find out just what our computers can and can't do. Look at your animations. They're like, come on, we can get this working now. Look how he spins. It's cool. Yeah, that spins. What, you broke it, maybe?
Well, I got the health box back. I'm just trying to fix the other part.
Oh, the moving right.
Yeah, and
Yes, I have
one box instead of.
Well, then it's just a matter of flipping the rotations. Then you'll move on. But, so what it would have been is change your 0 here.
Well,
See, you flipped 0 here, and then on this one you need to, oh, you have walk left and walk right. So you don't need to do that and all that. But now what I recommend is you could move the trees, turn that off, and you're back to the center there. So now you can see your trees here. Figure out where, okay. So the trees are here. Now then this is when your 1200 minus 1200 is one location.
And that's when you
and
can't
it's going to be minus 52 is the
Nice.
other
Fill this
one.
one.
Those are just the two numbers, give or take.
And then just figure out which one's that.
Yeah, put them in the right one and it should work. Really? You're gonna go there with me? Alright.
You gotta get a sketch you made.
Oh, the sketch?
hey, that's cute.
See if I can actually tear it out without ruining it.
Sometimes that's
Is it moving?
That's a good game.
Oh, you're looping it here?
I know. So seriously,
So
oh,
it
yeah,
is.
Yeah, we don't,
So I
we
go
don't, we
in,
don't want to
I
have
find,
any, we don't want any of that.
pompous.
So it
I
has
used to
to
start with
on
the
itself.
pompous Bridget, like pompous names,
Even
and
though
the autoplace
when you
pompous
repeat
name
them,
generator.
Wow.
You can't update because that's why that would only be able to work with one.
No,
user.
you just think
So every 2 seconds it would be like, hey, I understand. Oh, ah.
So, what was your name again?
That was it. I thought there was a
Victoria.
stop, so then I
Can you spell
didn't
that?
care about the extra frames. Working?
Wait. Well, I said you were Jude, so you're Quentin Watson now. I think it's just kind of. I think it's
Have you ever seen
random. I don't think
cartoon
it's
Leaders?
weird.
So the creator of that, Johnny Vasquez, his claim to fame was Johnny the Homicidal Maniac was a comic book he made, which was incredible. Same kind of genius that can conceive of something like Invader Zim, and then one of the characters in it was Squee, was just been tied up for a while because Johnny was only like 6 episodes long as a destroyer kind of. And then he did Squee, which ran for a while. And then somehow he got picked up by whatever Cartoon Network to do Invader Zim. He's like, haven't you seen what I do? Really? They want me to do a children's show? All right. So, yeah. Invader Zim is like favorite cartoon season. So it's just it's very well done. Alright. It's doing something, alright. To do what though? Well, it's an error message, so we're good. So very helpful. And now, do you have a rock on screen that you're calling off on? Let's say here, trying to modify the rock. But if you have it on screen, well, because when you have an error message, so when you have error messages, it says compile out errors. In an error message, all of your code is broken. One misplaced character, nothing else. It's not like HTML, which language works if it's still. This is what it is. That is
This is like.
which is starts with this function check collision. That's it's not the minimized one. It's where it says function. So right at line 47. That's so now what's minimized is all the previous stuff that was just making them move on the key commands and the key press. I didn't minimize any of the new stuff. So you need to start putting that in because that's what we're going to go visit right now is that function. Hey!
Now my buttons are backwards.
Oh, well, that's a super easy to fix, though. All you have to do is now change, instead of minus, this one's minus, this one's plus, just flip your plus and minus, and then that fixes it. So nasty steel. All right, so having a score or having a health isn't really. Oh. If we look inside check collisions here, we will notice that currently it says when the player is overlapping or hitting or colliding with the obstacle object. We were just tracing out this message. Now I'm going to get rid of these comments just because I want to fit more lines of code on screen to make it easier to see. So we don't really need to trace out this ouch message because our health is going to do that for us. So what we can simply do is say when we're colliding with that, health is equal to health minus 1. Now if we want to make it hurt faster, you can change it from -1 to -2, -3, or -10, or -20, and you'll die very quick. Or at least you'll move into negative numbers. So all we have to do is say health is equal to this, and using the abbreviated version that we've talked about this evening, we could also do it as health minus equals 1. So line 50 and line 51 right here do the exact same thing. I prefer the shortened version, but you can go with the longer version if that makes you happy. These are doing the same thing. They are taking health and subtracting 1 from it. That's what those lines do. So we're saying make my health less. I'm going to just keep one of those. Get rid of the trace, don't need that anymore. So health is going to go down. Every time health goes down, we're going to see an update in my health text that it has a different health value associated with it. If we test the movie, we will see that when I am colliding, my health is now going down. And it keeps on going well past 0, so apparently this is one styling beetle who is able to deal with an extremely negative health value. So the health will go down by whatever this increment is per frame. At 24 frames per second, it's 24 frames, or 24 health points per second. So in approximately 4 seconds, I will reach a negative health value, which it's pretty considerable in game terms. So if I wanted it to go faster, I could do something else. Or if I just want it to go down just a little bit, but there's multiple obstacles or enemies I'm running into, so I don't want to lose too much per enemy. Otherwise, it makes it a pretty challenging or difficult game to play. So you have to balance that with how many enemies could I potentially run into? How deadly do you want them to be? You could make different enemies have different effects on your health, and some could have a positive effect instead of a negative effect. So some things you run into could actually be health improvers instead of health destroyers. So it's up to you to figure out what works best with your project. If we have more than one object, then we can start repeating this. And then we could have object number 2. It's going to be repetitive coding to have a large quantity of objects, but on the other hand, copy-paste is no big deal, and then we can make this work. So we have some more advanced programming techniques that we can use. We're not getting into it tonight, but we do have ones that we can use that will allow us to manage a kind of a collection of enemies a little bit easier without having to write it out each and every time. So from a coding standpoint, this would be considered redundant and not very well-written code. But from an easy to understand standpoint, this is going to be much easier until you start to get a few more concepts under your belt. So now, if I have a second enemy, then we can make the health go down as well. So we can, if you were to have a second one on screen, so if I have a second enemy over here and I change his name, so we can see there's my enemy. That's enemy 2. Here's enemy 1. If we test it, I'm running into one problem. You will notice that I never put any information in to tell my enemy 2 to move, or obstacle 2 to move. Because currently we're moving obstacle number 1, but I haven't told obstacle 2 to move. So we need to also update the obstacle the same way we're updating the world. So both obstacles, both world. Now we can see there's 1, there's 2, and now we could make it that the second one is much more toxic than the first one. So during that collision, instead of going down by 1, it goes down by 3. So we'll see a much faster degradation of the health. So we can, through that one fast, that's not too bad. Go here, and that's, whoa, that's bad. Now what we're not doing is any type of checking to find out, okay, has my health reached 0 yet? If my health reaches 0, then I may want to make something happen, such as my bug goes upside down, the bug dies, game's over. So we need to start figuring out what to do with that. But the first step, though, is to figure out how to hit these objects. And notice that I'm running into the object, and if I accidentally stop here, well, that's really, it'd be nice if when I run into the object that it doesn't just stay there, that it would do something so it's no longer toxic to me. So maybe it affects me, but it doesn't keep affecting me. And that's what we need to figure out next. My obstacles here, if we go into the obstacle, we'll see that the obstacle is similar to the character. We have a standing state, and I've built now my animation state for what happens during my collision. Now what's useful here is we can add in frame labels so we know how to track it. It also is useful on these so that we add in, I'm not sure, there we go, just unpinning. It's also useful inside that character. In our main movie, we told our player to stop. Now if we have 10 obstacles, 50 obstacles, or 100 obstacles, and we tell each one of them to stop, we could do that, but that gets to be a rather tedious operation. So what we can do, it's nice to have all your code in one place, but it's not the end of the world if we go into the obstacle here. So I'm inside the obstacle, I'm on its starting frame, and I can just add in a simple stop command. That now tells the obstacle to stop on its first frame, so it won't play. So now if I run this, I'm actually back to where I was before. So we can see there's my obstacle, health goes down, health goes down. Wow, I died quick. So we've died now at this point. Inside my collision animation, and so that we can reference it, we had standing and walking. So I have my basic, what was my standing, my opening animation. Here now, it's useful to give it a name. I could just reference frame number 10 because we'll be saying to go there, but I think it makes more sense to give it a name. So I'm going to call mine crash. I'm not using collide or collision or anything like that. I could, but what I find is if we reuse the same word in too many different places, our brains start to get confused as to, wait, collision, collisions, collide, but if we use crash, okay, that's totally different. There's no O's, no I's, it's an A. It makes it easier sometimes in the brain to keep things separate, even though we're going to be effectively making this crash happen based at this event. Just add some frames so I can read the label there and see what's going on, using F5 to extend it out. So that's inside my obstacle. So it's similar to standing and walking, but instead of walking, this particular animation pauses for a moment and then it blows apart. Boom. And at the end of it, there's one final keyframe after everything, and that keyframe just has a stop on it. We want that stop in there so that this animation plays, and we don't want it to then start looping on itself.
Wait, so why are they on two different layers?
So I've temporarily commented out that stop on this collision. If we go back into my obstacle, we'll see that that's called crash. If you construct all of your obstacles with the same frame label names, then it makes it easy when you're doing the coding. You're following the same workflow or process. Now, if I go up here, when we collide, if I collide with obstacle number 1, I can say obstacle number 1, go to and stop, and then we're going to say crash. So we'll send it to that frame. So when we do that, we will get to see it crash. So we say the instance, go to and stop, where we want to, and then where are we trying to send it. So obstacle 1 works. We can add it to obstacle 2.
And then the obstacles are just different.
So now I'm going to go back into my crash symbol here that explodes, and I'm going to reactivate the stop at the end so that once it explodes, it doesn't keep exploding. Now if we go here and run into it, we'll see it blows up, and now it's gone. And then my health isn't going down anymore because there's nothing for me to collide with. If I hit this one, boom, and it explodes. Now if that takes too long to occur, then we may want to rethink the animation and shorten that up a little bit. So if this is taking too long to happen because I have this little pause after the collision, if I want to speed that up, I can now get rid of some of these frames. Now when I collide, we'll see it happens faster. I don't lose quite as much health in the process. So in lieu of using more complex, trying to measure out timelines or timers, which will be forthcoming, I'm going to advocate that you make your animations fast enough so that you suffer minimal or the correct amount of damage that you want to see happen. The other thing that we can do with it is you can, in lieu of having your object explode like that, well, we could have it explode, but you can also just tell an object, and you can position it so it's no longer in harm's way. So a very common technique would be to set, say, the y value of an object equal to a ridiculous negative number. So if something is at minus 1,000, that guarantees we'd never be able to see it because it's so far off screen. And if you run your project, you'll see that when I run into it, boom, it's gone, and I only suffered 1 damage. So another technique in lieu of having the animations where things explode is when you hit them, they just gone, disappear. When they go away and disappear, then we're no longer being affected by them. That can be another solution that we can employ with it.
7,000 if you're standstill over one.
So we can set a cap on the health as a way to control the game so we don't get in this one where it's giving me positive, this one's giving me a negative amount. So to control that, then what we can do is we have it going up here, we have it going down here, and if we know that if this is the only one that increases it, we could just write the code in here, and you could say if health is greater than 100, which is our max, and we could set that 100 equal to a max value, so we'd have a max health variable, and then we could just update it up at the top of the code based on what's going on in our game, because that would also make it updatable that perhaps there's certain things we could run into that would give us a temporary increase in our health, putting it at a higher max value than what is the starting amount. So you could do that. But then we can just say if health is greater than 100, our current max health is equal to 100. So I've now referenced the number 100 here, I've referenced the number 100 here, I've referenced the number 100 here, and in the world of coding, then that means what we really should do is health max is as a number is now equal to, and I'm going to just say 100, or I'll even bump it up to 125. just so we can see that there's a difference. Instead of saying 100 here, I would say health max. So health is equal to my health max. Health max and health max. So when my health is greater than the health max, we go back and make it cap at the health max. So now we started at 125. We'll let the health go down, go here, and now it went back up. So now I can't park over something, especially if that something doesn't go away. So if we make it so the objects don't explode, so they stay there, we can now see health is going down, and then we can go back here and health is going up, but it caps at 125. Down, up, down, up. In real gameplay effect, we probably would want to reverse that, make the negative a faster negative and the positive a slower positive, so that it's harder to get your health back, so you have to play the game a little bit harder, or that would make, it would follow with what would be more of a standard paradigm that you would encounter in a game. So now health is going down fast, but now it's taking longer to get back up. Especially now if enemies are chasing you in a game where you know that you can't just park and wait and wait and wait for your health to recover, but you actually got to stay on the move because they're hunting you down. Then that would be a way that you could put that in, but the longer you stay put, the more likely things are to start chasing you. So in the game where we have the shadow factored into the player object, so if I look here, I can see I have my standing, I have walking, and now I have my shadow, and then I have my object. What I'm going to do is move the shadow down a little bit. Actually, I'm going to leave the shadow where it was. I'm going to move the player up so the player is no longer touching its shadow. It's my flying beetle here. So, all right, so we have the flying beetle. The shadow is now going to intersect it, and we should see the shadow is now doing it even though our beetle is floating on top of what's there. So knowing that and wanting to correct that, what we can do is realize that currently it's the instance of this whole beetle object or the player object. But what I really want to do is I want to make it so it's the bug, not the shadow, that I care about. So what we can do is now reference the instance name here of this bug, and I'll put it down so he's now intersecting it. Currently, if we look, the bug has no instance name, but if we give our bug, and we have to give both of these an instance name, and I'm going to refer to this one as bug for now. Over the course of the week, I'll probably come up with a better name, but bug is what we're going to use for the moment. And you can update the names to match yours. So I have bug, so inside of player. So I have a symbol and a symbol. I have my player artwork here, and this is now bug. When I go into my collision detection, I don't want player, but I want player.bug. So I want the object inside of player. That's what I care about. So I'm referencing the object inside of the player. So I can reference very specifically an object inside of another object as the object that I'm concerned about colliding with. Now if I go here, the bug is doing it. And what I'll do is I'm going to put it so that we can see the difference. So the standing one is able to collide here. But my walking one, when he's walking, he's going to be above it all. So then we'll know. Well, then we'll know that it works. So if we go here, So when he's walking, we can see he's not colliding. But now when he's standing, the standing one is colliding. He's above it. So it's good that when he runs, he goes above things, but he has to be careful where he sets down. Now I can work on getting it back. So we can see it's now not the whole player symbol, but it's the symbol inside the symbol that is doing the collision. I didn't make the first frame of this symbol before, but I did make it now. So we have the obstacle boom symbol here, and I have the obstacle standing symbol on the first frame. And now if I give the standing artwork only an instance name, so if we say obstacle standing here at this point, and I look back at the code, so if we say if the bug is hitting we reference obstacle 1 and then the instance object inside it, standing. So by referencing it more specifically, instead of player and obstacle 1, now it's player bug, obstacle 1 standing. If all goes well, health is going down. Oh, hang on, let's go put the explosions back in though. So the reason that we're getting the error message where it's trying to find something but it can't find something, it says hit test object parameter must be not null. So it says if player bug is hitting obstacle 1.standing, well, as soon as we tell it to go to the crash frame, there's no longer this standing to be accessible. So it has a hard time finding it as part of it. So we need to do some more creative coding, sometimes combining getting it off screen or doing some other things. But we're going to I'm going to finesse this a little bit to give some cleaner options for it, and we will revisit that next week along with timers and audio in the project.